Hi, in this lecture we will be looking at some of the data operations that you can do using pandas. So we are going to start off by creating a dictionary that is of cars. So we are going to create a dictionary which has these columns, IDs, model, make, price and weight, and then convert that one into a data frame. And this is how your data frame is going to look like after it has been created. It has 5 rows and then it has got 5 columns too, and the columns are ID, make, model, price and weight. The operation we are going to be doing on this data frame is a group by operation. So I'm going to be grouping price by make. So I'm going to be grouping price by make and create what is called as a group by object. This is a named object called grouped. This is called a group by object. I'm going to be saying cars df of price group by the make. So you can actually use multiple columns to group and multiple columns inside group by also. So this is how you create a group by object, and when you print this group by object, you're just going to say it's a series group by object. Once you create a group by object, then you can then use the group by object to extract data about various things. To start with, I will say group by dot describe. Now what this describe is going to give you is for every value in the group by thing, which is every value in make, it gives you some computation on the grouped value, which is the price. So it says count, mean, standard deviation, min, the quartiles. It gives you all these values for every make. For every make, it is giving you 4 prices. What is the count of price? What is the mean of price? What is the standard deviation of price and stuff like that. I can extract specific values by saying grouped.mean. When I say grouped.mean, it is going to give you for every value in the make, what is the mean of price. Similarly, I can say grouped.max. It gives you like for every value in make, what is the max of price. So once you create a group by object, then you can start querying the group by object to get different metrics for what you have grouped. You can also use the grouped object in a for loop. Like in this case, I am extracting make and price from the grouped, and then I can walk through this one and then print all of them. But you can also do other operations like getting the metrics from there, like the mean and standard deviation, and then using that value for performing any other operation that you want to. Moving on to some graphics. In this example, we are going to be seeing some basic examples on matplotlib. So first I'm importing matplotlib.pylab as plot and numpy as np. So first thing I'm doing to do that. Then I'm going to be creating 3 different variables with some dummy data. So data 1 is nothing but range of 100, which is 1 to 100. Data 2 is just a manipulation of data 1 to get some variable data like data 2 equal to, and data 3 is a sign of data 1. So 3 different data sets which I'm going to be using in the examples later. First thing I'm going to be doing is I'm going to be doing a plot of data 1 and data 2. And when I do this plot, it just goes and creates a graph like this of data 1 and data 2. Sorry, this might not be the right one. So you have to always use plot.cla to clear an existing graph before you start plotting anything new. Otherwise, it is simply going to overwrite the original graph and it may not be the right one. So always make sure that you clear the first graph that is already there before you print anything. So this is the first graph you get, data 1 and data 2. Next, we'll again clear and plot data 1 and data 3, which is the sign value of that. And this is how that is going to look like. If we don't do a clear, it is going to be plotting on the same plot again and again. So you will get multiple plots in that case. So this is how the value of the data 1 to 100 against the sign of that value is going to look like. It is a sine curve, so it is what it is expected to be. Then how do I create a scatter plot? Now scatter plot, I'm going to be doing a scatter plot on the price, the car price against the car weight. I'm going to be doing a scatter plot. And let's do a scatter plot and see how it looks like. You see there are 5 data points, each representing 1 row, and it shows the price on the x-axis, the weight on the y-axis, and cars that fall there. I've also colored this by the red color. There is a lot of these kind of things you can do in Matplotlib, like coloring, axis, labeling, and stuff like that. That is possible. There is exhaustive set of functionality in terms of what you can do with it, but we are not going to be delving too deep into that. Next, we go into bar plots. How do I plot a bar plot of the price itself? So the bar plot is going to look like this. What is for every car, I'm going to be plotting the price. Every car becomes a bar here. That's how I'm going to be plotting the bar plot price. And then I'm going to be doing an horizontal plot also. You can also do the plot to be horizontal, in which case the plot is going to look like this, as a horizontal plot, by using bar hedge. And you can use white text, because for every y-axis I can put some text in there to say what that particular bar corresponds to. I'm going to be putting the model name there, and now you see that the model name shows up actually as the Y labeling also. So you can also add more annotation to your plot by putting in the Y label, which is the car's name. Then comes the pie chart. I'm going to be doing a pie chart of the price of a car and then label it as the car's model name. So I'm just going to be doing a pie chart here, which is again pretty simple. So the pie chart shows you for every car what is the price. It shows you actually the percentage, not the actual price. So what is the percentage distribution of that price? So this is a simple pie chart that you can do using Matplotlib. Finally, I'm going to do a histogram. A histogram is the one that does binning for you. So I'm going to be putting a histogram of data 3, make the color as green, and then I'm going to be adding a title to use, X labels and Y labels and everything. So let's see how this one comes up as. So now when you do all this, you see that this is the histogram that comes up. The sign weights, the frequency. Frequency is the number of times that value occurs in the data set. And what value it is. So this is how the histogram for the sign value of a range of 1 to 100 shows up as. This is how you just do a basic histogram. Then comes a box plot. Box plot is, as we talked about, going to show you the 5 quartiles. Now what I'm going to be doing is I'm going to be doing a box plot for weight. So car's weight. And I'm going to be doing an individual box plot for every make. So for every make, there is going to be a box plot for weight. So then you can compare how the range of weights vary between these two types of cars. So this is how you call a box plot. First, I pass it a list of values, and then I'm going to be saying what are the labels I should be using. And here you will see the box plot showing up. The box plot is something we were going to be using a lot in the later examples. So this is how Toyota is going to look like. This is how Ford is looking like. You see that the Toyota's weights on average are lower than that of the Fords. You look at that and you can immediately make a lot of decisions here. First is you see Toyota's range is a lot wider than that of Ford. Toyota range of values in general is lower than that of Ford. The weights are shown on the y-axis. So the Toyota's weights are generally lower than that of Ford's. And Toyota has a wider range than compared to Ford. Even though Ford has only 2 data points and Toyota has only 3 data points, this gives you an indication of how the values are varying for the given make. So this is a pretty important chart. We'll be using this chart a lot in the upcoming examples. Thank you.